Let's begin by addressing two of the most common questions about XML. What is XML and what is it used for? So what is XML? XML is the extensible markup language. It gets its name from the X, M, and L in the words extensible markup language. And that word extensible is core to how XML works. It means you can extend XML to suit your own needs and represent your data however you need it. XML became a W3C standard way back in 1998. And the W3C, of course, is the World Wide Web Consortium, which is one of the standards bodies that proposes and standardizes various ways of working with internet-related technologies. So XML has been around for a while, and it's been in pretty wide use across many different industries. It is a tag-based syntax, very much like HTML. So if you're already comfortable working with web pages and HTML, then XML is going to look very familiar to you. It uses the same kind of tag syntax, the same kinds of attributes, and so on. Now, you don't have to be an HTML expert in order to use this course and learn about XML, but if you already know HTML, you're going to feel very much at home. Now, having said that, I want to point out that XML is not a replacement for HTML. HTML is a very specific tag set that solves a very specific problem, which is marking up web pages. XML is much more general purpose, and we'll talk about that more later in the course. It can be used to structure any kind of data. A key thing to remember is that X means extensible, and that means you can make up your own tags. So if you have a particular problem where you need to mark up some information, and there isn't already an existing tag set in XML for you to use, then you can make up your own. And again, we will see examples of this as we go through the course. But just remember, X means extensible. It's a way of defining tags to mark up data and solve particular information-related problems. XML is also the foundation of several web and other technologies that you may have heard of. So, for example, Microsoft Office uses XML to build Word, PowerPoint, and Excel files. Another very common use of XML is the Scalable Vector Graphics standard known as SVG, and this is widely used on the web to display graphics. Many popular web services are also based on XML, particularly in enterprises. These provide a way of using various data services and APIs, or application programming interfaces, over the web. There are many different ways of exchanging data over the web using web services, but XML is one of the main ones. So if you work with web services, chances are sooner or later you will run into XML. XML is also the foundation of publishing standards called RSS and Atom, and you may have heard of these. These are technologies that are commonly used for publishing information, such as blogs. And of course, DocBook is a very popular XML standard for working with technical documentation, which can then be transformed into whatever output is required: PDF, HTML, Word, almost anything else. Now let's talk a little bit about what XML is used for. XML is used to structure and describe information. And if you get very little else out of this course, remember this sentence right here. XML's purpose is to take information and apply structure and meaning to it. And we'll see examples of that as we go through the course. From the very beginning, XML was intended to be used over the internet. The developers that sat down and wrote the XML spec knew that XML would be used as an internet standard, and it was designed with that in mind from the very beginning. XML is also designed to be human readable. That is, a person is able to look at a part of an XML document and be able to at least identify the parts of the code. XML can be used to exchange data between disparate systems that may have never been intended to talk to each other. So, for example, a bank might be using a very old computer system, and they might want to create a new application that lets that data be accessed by newer systems, and XML can be used to bridge those kinds of gaps. In addition to XML itself, there are certain related technologies that make working with XML easier and more productive. The first is called XPath, which stands for XML Path Language. And the reason it's called XPath is because it uses a path-like syntax to perform queries on XML data. If you've ever worked with folder and directory names and file names, you'll notice that most computer systems organize those as a path. So there's a drive name followed by some folder names down to a file name. And all of those are usually separated by some kind of a path character, like a slash or a colon. XPath is very similar, and it's used to find and extract information from XML documents. And we'll work with XPath later in the course. The next is called XSLT, and that stands for XML Style Sheet Language Transformations. Now, you might see that word style sheet and think, oh, yeah, well, that's kind of like CSS. And it sort of is. XSLT can be used to style XML information, but the real important word there is transformations. XSLT provides a way of taking XML information and transforming it into something else. And that something else could be another XML format, or it could be PDF, or a text file, or it could be a web page. It could be pretty much just about any other kind of file format. And again, we'll work with XSLT later in the course. Next is XQuery. It's a way of extracting data from XML as if it were a database. So the same way that you would use SQL to extract information from a relational database, XQuery can do that with XML data. XQuery is kind of like XPath. I talked about that a few minutes ago, but it's a more advanced querying form than XPath gives you. In fact, XPath is sort of just a derivative form of XQuery, whereas XQuery is used for extracting information from XML in a very advanced way. Using XQuery, you can build really complex queries that search multiple XML files to extract data. Then there's XPointer and XLink. These create links between and within XML documents. And conceptually, you can think of these as similar to the link tag in HTML, but it's just a lot more powerful. Now, those last three, XQuery, XPointer, and XLink, those are fairly advanced, and they could take up an entire course just on their own. So in this course, we're only going to focus on XPath and XSLT, which are in fact the most common, and we will see more of later on in the course. So recall earlier, I stressed the importance that one of the main purposes of XML is to structure and describe information. We're going to take a look at an example of that right now. So to illustrate an example, let's consider some information that you would typically find on a business card, such as a person's name, right? Various phone numbers, maybe an email address, and there might be some additional information on a business card, but just to keep the example simple, I'll leave it at this, right? Okay, so which one's my work number? Well, you don't know, right? Which is why business cards usually also provide things like labels that clearly identify what the information means. So once the labels are visible, you can see, oh, okay, the work number is the 800 number and so on. Those labels are there to describe the information that's on the business card. And this is an example of what XML does. It applies descriptions and structure to the data that you are working with. So if we were to take the same example and build it in XML, we might be able to structure it in a certain way. Now, don't worry too much if this doesn't make sense right away. We're going to get more into XML syntax as we go through the course, but I just want to show a quick example. So to represent our business card in XML, I might have a tag called business card, and the business card tag might be the root element that holds other data, like, so for example, a name. And there might be various tags like phone, and each phone tag might have an attribute that describes what kind of phone it is, right? Home, work, mobile, and maybe I have a tag for email. And if you're familiar with HTML, you might be looking at this and saying, well, wait a second, business card tag, phone tag. I've never seen anything like this in HTML before. And you're right. I just made these tags up to hold the business card data. Now, if there was an existing business card XML tag set that I could use to solve this data problem, I could go ahead and use it. But imagine for a moment that there's no such XML standard. And the truth is, I don't know if there is or isn't, but I could decide to create my own XML language called business card. Remember, the X in XML stands for extensible. So if you have a particular data-related problem or task, and you want to use XML to solve it, you can either use an existing XML language, if there is one, or you can just make one up. In this case, I decided, well, if I'm going to structure a business card in XML, I'll need a root tag, and I'll just call it business card, and I made up the tags for name and phone and email. And if I wanted to add other tags like address and company name, I could do that too. Now, once I've done this, right, once I've collected this data here in XML, I can now take this XML data and give it to any other XML-aware program. And that program can then parse and extract data from this business card. Now, that program may not know what a business card is or what the various tags mean, but because XML is an open text-based standard, any application that knows how to work with XML would at least be able to extract the data from the business card. Just like any other technology, XML has its advantages and drawbacks. XML has several advantages. First, XML keeps content separate from presentation. You can take the data that your application uses and store it separately from the presentation. That way, regardless of what kind of presentation medium you're using, whether it's mobile or desktop or print, you can just simply flow the data into various layouts. And you can maintain a good separation between the content from how it is presented. XML has the ability to combine data from many different data sources into a single place and keep them from conflicting with each other. This makes it easier to work on data from different sources and to derive new data from those sources. XML is also an open format that can be read by many applications, and many applications today also have the ability to output XML, like Microsoft Office. So because it's an open format, you can store your data in a way that can be read by many different applications, even those that haven't been written yet. XML can be used both on the client and the server, because remember, it's just a data format. Today's modern browsers, Firefox, Chrome, Safari, Edge, they can all work with XML data. You can use XML data in your applications, whether they are client or server apps. They're just a really good way of storing information. XML has wide support in multiple languages and runtimes. You can use XML from Python and C# and .NET and Visual Basic and Java and lots of other programming languages, even JavaScript. That's the nice thing about XML. It doesn't change from language to language. And this support extends to different runtime platforms. XML can be used on the .NET platform or Java or iOS or Android. You can use XML just about anywhere. XML also makes it possible for disparate systems to exchange data, and these could be systems that were never designed to talk to each other in the first place. So let's imagine that you have two computers and you want to share information between them. The problem is one of those computers is modern and speaks a certain language, and the other is a little bit older and only knows a different language. So what do? Well, XML can be used to help solve this problem. XML can create a bridge between these two computer systems so that they can exchange data even though they're not aware of each other's native way of working with data. Now, XML does have some drawbacks. First, it's not suitable for very large data sets. And when I say very large data sets, that can vary. It's really up to you to decide. But generally, once you start getting into multiple megabytes of data, XML is probably not the most efficient way of working or storing it. XML does make it easy to interchange data, but as far as storing large data sets, database is probably still the way to go. Some data formats, like JSON, might be better in some cases, depending on how you're going to use the data. If you know the data is going to be used in a JavaScript execution environment where it's immediately turned into native memory objects, for example, there are some cases where JSON might just be more efficient. Some data types, like images, aren't represented well in XML because it's a text format and images aren't. Now, there is a way to do this. You can encode images and insert them into XML documents, but that gets ugly pretty quickly. And even though it's possible, it may not always be the best way of doing it. And XML, when it gets really complex, it can be hard to read. So if you're not planning on having humans read your XML files, this may not be a big deal, but it is something to be aware of. So now that we've seen what XML is and what it's used for, and we understand some of its advantages and drawbacks, let's take a look at some real-world uses of XML. So first, I've got the BBC website open here, and you can see the URL I'm visiting there on your screen. And as I mentioned earlier in the course, RSS is a data format that is typically found in publishing. It's commonly used for blogs or other syndicated content that is updated periodically. And you can see if I scroll down here on the BBC site, there's a whole bunch of RSS feeds. It's all these links right here. These are all XML documents that list various different news-related items. So let's go ahead and click on one of these. I'm going to click on World. And when I click on that, you see I get a screen full of XML code. And let me just zoom this up a little bit so we can see it a little bit better. Right here at the top of the page is the root tag. You can see it's called RSS. And then there's a whole bunch of XML that describes the content, right? Like story titles and links and images and stuff, okay? You can see that there's a variety. Here's a copyright tag right here, right? We've got publication dates, all this kind of stuff. And each one of the stories in this news feed is described using XML. So other applications like browsers, for example, that know how to read XML and know how to associate style sheets with them can give users a nice experience in reading their news stories. Now, I don't expect you to understand all this code right now. We're going to get deeper into this as we go through the course, but you can see that by using XML, BBC is able to provide a nice data-driven interface to their news stories. So let's take a look at another example. So this is the National Weather Service page for their XML feeds for weather data. And using this page, I can search for weather feeds for a given U.S. state. So let's go ahead and search for, well, Washington's usually got some good weather. So let's go ahead and choose Washington and click Find. All right, and this results in a rather large list of weather stations throughout the state. You can also see that the weather data is being provided in both RSS and plain XML formats. So let's scroll down. Let's take a look at Olympia Airport. Okay, and I'll click on the link for that data for the XML. Now, in this case, I'm being given a nicely formatted web page that displays the latest weather data. However, when I right click and choose View Page Source, right, you'll notice that this isn't HTML. It's XML code that's being formatted as HTML. And again, let me zoom this up a little bit. So this is all XML code, right? So if you were thinking you're going to see HTML, no, it's not. It's XML. And you can see the weather data that's embedded here. And the reason it's being formatted as HTML is because of this style sheet declaration right up here. This is XSLT, and we'll look at this later in the course. This style sheet is taking this XML data and in real time translating it into HTML. So that's pretty cool, and we'll see that later. Let's look at one more example. And this example comes to us from Wikipedia, and it's an Wikipedia entry that describes the Microsoft Office XML file formats. So in addition to being able to save Office files in their native format, Microsoft also supports saving Office files as XML documents. And if I scroll down the page, you can see there is a list of file formats that are supported, right, in XML. That's these file formats right here. And if I scroll down a little bit more, there's some examples of different XML formats from various Microsoft products. This one here is from Microsoft Word, and you can see there's a whole bunch of XML code that describes a fully functional Microsoft Word document. Now, this one is fairly long, but it's a working example. If we scroll down a little bit more, here's one from Excel, right? So it uses XML to describe the contents of an Excel spreadsheet. So this should give you an idea of just how widespread XML is being used for various different purposes. I mean, just in this short video, we've seen examples for displaying news information, weather data, and file formats for Office. So XML is really flexible and helps you solve a wide variety of different data-related problems. In this chapter, we're going to learn about the basic rules of XML. We're going to start off by learning about the contents of XML files, where we'll discuss the types of content that you'll find in XML data. Then we'll investigate proper XML syntax, things like nesting rules, how attributes work, and other things you need to know to make sure that your XML files are able to be processed correctly. Next, we'll see how to make valid XML documents This is a concept we'll revisit later in the course when we talk about document type definitions and XML schema. And then finally, we'll wrap up with a discussion of XML namespaces, which provide a way for you to include XML data from different sources and avoid collisions with other tag names when you do so. So let's start off by learning about the types of content that XML files can contain. There's about a half dozen or so types of XML content that you'll run into when working with XML data, and I've listed the most common ones in this table. There's the XML document declaration, elements and attributes, comments, character data, processing instructions, and entity references. Some of these content types are used in this actual XML example. So here at the top, we have the XML declaration. We have elements. You can see that we have business card, name, and phone. We've got some unparsed character data along with some text. We've got some attributes, and we even have an entity reference like this copyright entity right here in the XML. And if you're already familiar with HTML, then some of this content structure probably already looks familiar to you. Let's examine each of these a little more closely. The document declaration looks like this. It's an opening bracket with a question mark, followed by the letters XML, and then a version and encoding, and then an optional standalone declaration. Now, this document declaration is technically optional, but the W3C recommends using it. You can make XML documents that don't include this. I don't recommend it, though. It's always a good idea to include the document declaration. It identifies the file as an XML document, and it provides a place for the encoding and standalone attributes. It has to be at the very beginning of the XML file. You can't even have any white space before it. The encoding attribute defaults to UTF-8 if you don't include it, but it's a good idea to explicitly include it. And if you decide to use a character set other than UTF-8, like Unicode UTF-16, for example, this is where you would put that declaration. The standalone attribute identifies whether or not the document stands by itself or it depends on something else. If it requires other data, then you should set the standalone attribute to no. Next are XML elements, which are also called tags. And if you've worked with HTML, these will look entirely familiar to you. Elements must have valid names. They can begin with an underscore or a letter, followed by letters, digits, periods, hyphens, or underscores. They can't use the string XML in any case combination because the W3C reserves that. So let's see some examples of valid tag names. Each of these examples follow the rules outlined above. So I can have an element with underscores, numbers, or periods in the name, and I can mix and match hyphens and underscores. So these are all okay. Here are some examples of invalid tag names. So for example, you can't begin a tag with a number. You can't have invalid characters in a name like the hash symbol and an ampersand. And of course, you can't use the letters XML even in different cases, right? Those are reserved. So XML elements must have valid names in order to be processed correctly. Attributes in XML work the same way they do in HTML. They are specified on opening element tags only, and they have to start with a letter or an underscore similar to element names. They can be followed by digits, letters, hyphens, periods, and underscores. And just like tag names, attributes can't start with XML because that's reserved. Attributes only appear once on a given element. You can't have the same attribute name over and over again. Comments are intended to embed information inside XML data that are readable by humans. They are analogous to comments in other programming languages that you might have seen, such as JavaScript. They don't actually affect the document data. They're just there for people to read them. They're defined with an opening angle bracket followed by 2 dashes and an exclamation point, and they end with 2 dashes and a closing angle bracket, just like they do in HTML. And just like in HTML, they can go pretty much anywhere except for inside element brackets and before the document declaration. So here's an example of an invalid comment because it's inside of an opening element tag, but this is okay. You can put comments inside of elements. All right, moving on, we have character data sections. These are specified using the CData specifier, and they're part of the document content, but the actual contents of CData sections are not parsed by the XML parser. So the parser skips the CData's content. It doesn't try to figure out what kind of data it might be in there. They're defined by using an opening angle bracket followed by an exclamation point with a square bracket, the word CData, and then another opening square bracket. And then you have your data in there. And then they close with two square brackets and a closing angle bracket. They're typically used to contain unescaped text data, such as characters that aren't legal within the parsed XML. So, for example, if I had an XML document that contains a script tag, and inside that script tag I had a function, right? Normally this code would cause a problem because that return statement there with a less than b, right? That contains an angle bracket. So the parser would look at that and say, oh, an element tag is about to open up. Now, this isn't an issue in HTML because the browser knows what a script tag is. And when the browser is parsing the script tag, it knows not to treat angle brackets as tags. XML parsers don't know this, right? Remember, you can make your own tags up. And so inside of a tag, if you have an illegal character, that's going to cause a problem. So the way you get around this problem is by enclosing this inside of a CData section. And this will cause the parser to simply skip over the contents. And then you could put whatever characters you like in there. Processing instructions are a way for XML content to deliver special instructions to the XML parser itself. They have the form of an opening angle bracket followed by a question mark with a target name and an instruction, followed by a question mark and a closing angle bracket. And if you're paying attention, you might be saying to yourself, well, wait a second, that's the same format as the XML document declaration. And you're right. The XML target name is reserved because it's part of the document declaration, but a processing instruction can start with a number or letter and be followed by digits or letters or hyphens, periods, and underscores. And an example of why you might use a processing instruction is that maybe you have an application that has multiple spell checking modes. And in particular, you might want to indicate to your app that a particular language should be used when the document is being spell checked. So in this case, I would specify that the spell check mode should be British English rather than American English, for example. It's just a way for the XML data to contain information that the parser itself can use to affect how the parsing is executed. And then finally, let's look at entities. Entities are intended to help modularize XML documents. They provide markup for characters that would otherwise be illegal in XML content. So first you have general entities, which are replaced by the parser with a full string. And an example of this would be, copyright or author, and you can define these to be a string of content that will get replaced by the parser when the XML document is being parsed. There's also character entities. So for example, if you wanted to include a specific character which is not available on the keyboard in your XML data, you can do that by using an ampersand, followed by a hash symbol, and then the character's code number. Some character entities also have special names. So for example, the ampersand itself is specified by ampersand and then AMP and a semicolon, or the quote character, which is an ampersand, the letters QUOT, and then a semicolon. All right, so that's a quick summary of XML content types, and you can feel free to refer back to this video if you want to. In the rest of the chapter, we're going to learn about the rest of the requirements for creating XML documents. XML syntax is a little more strict than what you might be used to if you're used to working with HTML. So let's cover the basic rules of XML syntax here. So first, XML documents must have a single root tag. And if you remember back to the business card example that we saw earlier, the business card tag was the root tag in that particular document. XML documents must also be what is called well-formed. In other words, there are certain syntax rules that XML documents have to adhere to. The first is that empty tags have to be closed with a slash before the closing angle bracket. Now, this is different from HTML, for example, where image tags are empty, but they don't necessarily have this trailing slash. And the reason for that is because the browser knows what HTML is. It knows that there's this tag called IMG. It knows that it's empty, right? It doesn't have other tags inside of it. In XML, remember, you get to make up your own tags, and the program that's parsing the XML may not know what a particular tag is or what it means. So you have to indicate that a particular tag is empty by including that trailing slash before the closing angle bracket. Attribute values can't be minimized. And you typically see this, for example, when you're working with select lists in HTML. So on option tags, you can just simply put the word selected as an attribute with no value, and then the select list will show up in the web browser with that option selected. Now, in XML, again, there's no way for the XML parser to know whether your attribute requires a value or not. So the way you get around this is by putting the name of the attribute and then equal to the name of the attribute as the value. So you basically have the name of the attribute equals the name of the attribute, and that's how you get around this. Attribute values also have to be inside of quotes, either single or double. Now, in HTML, you can get away with just putting attribute equals value, but in XML, that doesn't work. You got to have the values inside quotes. And then finally, tags have to be properly nested inside of each other. Now, in the old days, browsers let you get away with this because they could basically figure out what you meant. So if you basically had like a bold and an italic text, and you had opening B tag and then an opening I tag, but then you closed the B tag first before the I tag, the browser could forgive that, right? Because it could figure out what was going on. In XML, that's illegal. You have to have the tags properly nested and be completely inside of each other. In a previous video, I talked a little bit about proper XML syntax, which is needed to make sure that the XML parser is able to properly parse your XML file. But above and beyond that, there's also a concept of what's called a valid XML document. So let's quickly review. Suppose you have an XML parser represented by these gears. So you give it an XML file, and then as long as the syntax is properly formed and you've correctly named your elements and you followed all the rules, then good results come out the other side. And that's what we mean by saying that an XML file is well formed. But there's another way to make sure that XML documents are what's called valid. So you can produce a set of rules that you supply to the parser, and these are applied to the parsing process in addition to the well-formed checks. So, for example, you can supply rules that say things like, tag A is only ever allowed to occur inside tag B, and attribute X can only have these values, and so on. If the XML parser processes the document correctly and the document content passes the rules that you've specified, then the document is valid in addition to being well formed. So there are a couple of ways to do this. The first way is called document type definitions, also known as DTDs, and the second way is called XML schema. Document type definitions are simple to use, but they're not very powerful. They give you basic ways of making sure that certain content means basic rules. They're written using a syntax that's somewhat different from XML. It's similar, but it's not exactly the same. XML schema, on the other hand, is much more powerful and flexible than DTDs are, and they are written using XML syntax rules. We'll take a look at both document type definitions and XML schema later on in the course when we get to the sections on making valid XML documents. Let's wrap up this chapter by talking about XML namespaces and how they are used. XML namespaces have the form of the letters XMLNS and then equal to some character string. And if you've used HTML before, you might have seen this. It sometimes appears on the HTML tag. Now, the character string that goes inside that XMLNS attribute just has to be unique. It's usually a URL because those are unique, but it doesn't have to be. The XML specification says it just has to be a unique value. And in fact, the XML parser doesn't even try to access whatever is at that URL. XML namespaces are used to prevent different tags from different languages from conflicting with each other when you try to use them in the same XML document. Remember, X in XML stands for extensible, so I can define my own tags. If I want to create an XML document that includes tags from different tag sets, there's the potential for someone using the same name for a tag that I've decided to use for my own purposes. So let's take a look at an example. Suppose I have an HTML file with a table in it. And HTML tables have things like table rows and table cells. They're used to lay out tabular data. However, if I create an XML document, and I work for, say, a furniture company, to me, a table means something completely different. I'd have a table, and my table definition for furniture might have a type, right? It might have a price, the material it's made of, how many I have in stock. If I try to use my XML table inside my HTML table, that's going to cause problems, right? The browser's going to look at the furniture table tag and say, wait, what's this? What's a type? What's a price? I've never seen this before. So if we want to take the XML data from the furniture table and include it in my HTML file, I need a way to make sure that the two table tags don't collide with each other. And this is where XML namespaces come in. So the way you'd solve this is by defining an XML namespace for your tag set. Now here on my HTML tag, I'd have the XML NS equals followed by a namespace definition. So in this case, I've got the XML NS and then I've got a colon, and then I put these 4 characters FURN for furniture, and I'm pointing to a URL that I just made up. I have no idea whether that actually exists or not. This is just illustrating an example. So here's how you would use this. Inside my HTML, I would define my table just like I always do. And I'd have my table tag, my table row, right, table cell. But now, in order to include the furniture table definition, I simply put the prefix of my namespace name in front of the tags that appear in my furniture table namespace. And you can see that that matches up with the namespace definition I included at the top of the file. So now, when the browser comes across a tag that has the fern prefix in front of it, it's going to say, oh, okay, well, I don't know what this is, but it's a well-formed tag and it's embedded in my content and I'll parse it, but I'm not going to try to interpret it or figure out what to do with it. It uses this word table, but it's got this prefix, so it's not an HTML table, so I don't have to worry about it. So this is how XML namespaces are used so that you can combine data from disparate sources without having to worry about tag name collisions. All right, we've reached the point now where we can start working on our first XML file, and I'm going to do that here in Visual Studio Code. Now, again, if you're not using Visual Studio, that's fine. Your favorite text editor will work, but you'll have to find another way to preview the file in the browser with a local web server. So here in Visual Studio, I'm going to open up my Chapter 3 folder, and I'm going to click on the first XML file, .xml, and open that in the editor. And you can see the contents of the file are, well, pretty much empty except for the XML declaration. So let's go ahead and create our XML content. So I'm going to create a tag called first tag. And you can see that the XML extension is doing a nice job of doing the code complete there for me. And so inside the first tag, I'm going to put some text. All right, this is our first XML file. And I'll put a comment in here as well. Let's see, this is a comment in the file. All right, let's go ahead and save that. So we have a root element, which is called first tag, right there on line 2. And then down here on line 5 is the closing tag. And inside the first tag element, I've got some text and a content. All right, so let's go ahead and save this and preview this with Live Server to see how this looks in the browser. So what I'm going to do is right-click, and I can either do that here in the source code and choose Open with Live Server, right, because that extension adds this menu item, or I can do it right here on the file itself. It is Open with Live Server. So when I do that, so my browser will start up, and it takes me to the home directory of my folder. So let's go into the Start folder and into Chapter 3, and let's click on First XML File. All right. And so you can see that the browser opens the file and says, this XML file does not appear to have any style information associated with it. The document tree is shown below. So the browser is just simply showing the contents of the XML with no styling information. It's just the raw XML data. So before we get deeper into working with XML using a variety of APIs, let's first take a look at how we can work with XML in a simple way directly in the web browser. So in a separate video, we'll see how we can give our XML an appearance by associating some styling information with it. But if you made it this far, then congratulations, you've made your first XML file. There are a lot of different ways to work with XML data depending on what your goals are. Later in the course, we're going to see several different ways of working with XML, but first, let's start with something simple by giving our XML a visual appearance. In the previous video, we built our XML file and then previewed it in the browser without any styling information. In this example, we're going to see how to associate some styles with XML tags. So let's begin by picking up where we left off from the previous video where we have our finished XML code. And if you did the previous exercise, then this document should already have some content. If not, go back and do the previous video now. Let's also open up the first XML file.css file. And right now it's empty. So I'm going to add some CSS code to fill out this file. And before I do that, you might be wondering why you would want to add CSS to your XML. And the reason is that for some relatively simple scenarios where you're just embedding some XML into your web pages, this is an easy way to give the data a visual appearance. We will see other ways of doing this later in the course for more complex data. So I'm going to define my CSS style, and I'm going to do that the same way that I would define it for any other HTML tag. So I'm going to use the tag name and then define the style. And then internally, I'll give it a display, and that's going to be block. And we'll give it a font family. And let's use Arial and Helvetica and so on. And then I'll define a font size. Let's make that large. And then let's give it a color. Let's make the color blue. All right, so let's go ahead and save this. So I'm defining the CSS the same way I would for any HTML tag, right? I have the tag name, and that corresponds with our XML tag. And I've defined the CSS just like I would normally do in any other CSS style sheet. All right, and let's go ahead and try this out. What I'm going to do is save this file and preview using the live server. So let's go back to the source. And I'll open with the live server. So let's go into our start folder now that the live server has been started, and I'll open this up. And then what you'll see is that once again, you're just seeing the XML source. And this is happening because we haven't associated the style sheet with the XML file. So now we need a way of associating that style sheet with this XML data. So let's go back to the code and fix that. So what I'm going to do is in my XML file, I'm going to add the following line. I'm going to create a processing instruction called XML-stylesheet. And then the type is going to be text CSS. And the href is going to be first XML file.css. And then I'll close that off. All right. So this processing instruction is going to tell the browser that there's a style sheet that goes along with this XML file. And the type attribute is set to text/CSS. And I've got the href pointing to my CSS file. All right, so let's go ahead and save. Let's go back over to the browser and refresh the page. So let's go back to Edge and let's refresh. And now you can see, right, that when I refresh, the XML document tree has gone away and it's been replaced by the text that's in the file. And sure enough, it's Arial font and it's blue and it's relatively large. So by using an XML style sheet declaration, you can associate CSS information with your XML data and give the XML an appearance. This approach works well when you have small amounts of XML you want to display. Usually in a web page, usually you would just put this CSS style along with the rest of your styles. And later in the course, we'll learn about other ways of working with XML to give them a visual appearance that are a bit more flexible and powerful. Now let's take a look at a slightly more advanced example associating CSS style sheets with XML. So here in chapter 3, I'm going to open up the business card no style XML. And so this is the business card XML data that I showed previously as a theoretical example. And as we did in the previous example, let's associate a style sheet with our XML. So I'm going to add the XML style sheet association dash style sheet, and that's going to be text CSS, and the href is going to be business card .css. All right. So now, again, let's go ahead and save this. So far, this isn't any different than what we did in the previous exercise. All right, but what I'm going to do is if you look at the business card CSS, you can see that I've got a root tag for business card, and it defines a whole bunch of properties like font family and background color and width and so on. So let's go ahead and bring this up in the browser and see what it looks like. So I'll open this with Live Server. And then in Start Chapter 3, let's open up that XML file. All right, you can see the XML has an appearance, but all the contents of the business card are just kind of jumbled together, right? They're not on their own lines. It's all squished up. They're not labeled properly. So let's go back and fix that. So in the previous first XML tag example, we only had one tag with some text content. And what we have now is a root tag with other tags embedded inside it. And the browser is just taking the text content of all those tags and putting them into the browser window without styling them individually. So I'm going to fix that by adding CSS definitions for each of the individual tags. So let's make one for name. And for name, we'll give it a color. And I'll make that color this. And then we'll give it a font weight of bold and a font size of 140%. We'll display it as block, and we'll give it a bit of a margin bottom. All right. And then we'll do the same thing for the phone. So let's create a phone style, and we'll give it a font size. And I'll make that one 90%. And we'll give it a color. And let's give it a color. We'll give it this color. And we'll have the display also be block. Whoops. And then finally, let's do the email. So email will have a color as well. And let's just copy the properties from the phone. So we'll have a display of block and a font size. All right. Okay. And we'll give it a margin top of, say, 3%. All right. So now that I've made some changes, all right, let's go back and refresh the browser. So let's refresh. Okay, so now when I refresh, you can see that each of the individual elements are being styled individually, right? So now we have the name with its color, the phone numbers, and the email. They all have their own appearance. Now, of course, if you're paying attention, you'll notice that there are no labels, right? So if we look back in the XML code, right, we've got things like mobile and work and fax. I've got an attribute called primary, which indicates this is my primary phone number. So we want this data to show up in the styled XML along with labels like name, phone, and email. So we can go into CSS and fix that. So what I'm going to do is for the email tag, I'm going to use the pseudo class before, and I'm going to insert some content before that. And it's going to be a label that says email. And then I'm also going to put some pseudo classes on the phone. So we'll have phone before, and that's going to be content. And the content is going to be the attribute value of the type attribute, followed by a colon and a space. And then the phone tag that has a primary attribute. After that, I'm going to put some content, and that's going to be a space with the value of the primary attribute, which is just going to be the word primary, followed by a closing parentheses. All right, so now let's save that. And now let's go back to the browser and let's refresh. And now you can see that when I refresh, the labels are now showing up, right? So in the case of the phone tags, I've got mobile, work, and fax. I've got the primary phone number labeled. The email has the email label in front of it, and so on. So just by using CSS, we were able to apply some, relatively advanced styling to our XML content, showing not just the contents of the tags, but decorating them with labels so that the user gets some useful information out of the content. In the first few chapters of this course, we learned the basics of XML and saw how to create XML content. We also used CSS to give the XML a visual appearance in a web page. Over the next several chapters, we're going to examine different ways of processing XML content using a variety of different technologies and approaches. In this chapter, we'll see how to use the document object model, or the DOM, to exercise much more granular control over XML content. I'll be using the standard APIs that are available in the browser, but you're not limited to the browser. There are other implementations of the document model that you can use in many other languages and systems, both on the client as well as the server side. And so what that means, just to be clear, is that you're going to have to be comfortable working with HTML and JavaScript for this part of the course. The document object model is a standard set of APIs or functions for working with document content. It is platform, browser, and language neutral. In other words, it works the same across different implementations. The examples I'll be showing you here use JavaScript in a browser, but there are DOM implementations for other languages like Python, Java, C#, and so on that work on the client and server side. The DOM represents the document content as a tree structure, and the contents of that tree are called nodes. So let's take a look at an example and see how this works. So let's suppose I had a regular HTML web page. And yes, this is HTML, but the concept is the same with XML. So this is a pretty simple page structure. I have my HTML root tag, and inside that, I've got the head and the body. The head has a comment and a title, and the body has a paragraph with some text. So the DOM represents this document in memory as a tree structure of objects. So at the top is the HTML, and inside the HTML are the head and the body, and these are said to be child nodes of the HTML node, which is the parent. Then inside the head and the body are the title and the paragraph. And so far we've talked about tags, right? But the actual text content of these tags are themselves nodes within the DOM. So inside the title tag, right, there's a text string that says document. And inside the paragraph, there's a text string that has the value paragraph text. So each of these is a separate node in the document. We can express the relationship between these nodes using family terms. So let's use the head tag as the reference point. So in this example, the HTML tag is the parent tag of the head, and then the comment and title tags are child nodes of the head tag. The text inside the title is a child of the title node. The comment is the first child of the head, while the title is the last child property. The head and body nodes are siblings of each other, and specifically the body is the next sibling of the head. And you're going to see this kind of terminology used throughout the DOM API. All right, so let's talk about some important DOM properties that you'll come across when you're using the API functions. For example, the node name property is the name of the node. For a tag, it's going to be the tag name. For things like comments and text nodes, it will be a special string like hash comment or hash text. The node type property is the node's type, and it's a numerical value that represents what kind of node it is. So there's numerical constants for things like elements, comments, text, so on. The node value property is the value of the node, and this varies based on the node type. So for example, the node value of a text node would be the text content. And there's the attributes property, which is only valid for elements, and it's an array of the attributes and their values that appear on that tag. There are also properties for accessing the family relationships of nodes. So for example, if you have a node and you access the parent node property of that node, that gives you the parent of the node that you're looking at. If there isn't one, for example, if you're already at the document root node, then that value is null. There's a child nodes array, which lists the child nodes of the current node. And again, if there aren't any, then it's just an empty array. You can also ask for a node's first and last child. You can also get its previous and next sibling. There are functions for taking nodes and moving them around in the document. For example, the append child function inserts a new node at the end of a given element's existing children. The other functions do what they say. For example, remove child removes an element. Insert before inserts a new node before the given node. You can also replace an existing node inside a parent with a new one by calling the replace child function. There's properties for doing things like accessing and creating document content. So for example, the document element refers to the root document element node. There are create functions like create element, create text node, and so on that allow you to create new nodes of the relevant type. There are functions for accessing nodes in the document. So for example, the get elements by tag name function will return an array of tags that match a given tag name. So for example, you can ask the document to get elements by tag name and give it something like the letter P, and it will give you all the paragraph tags in an HTML file. You can also call get element by ID, and that will return a single element that matches the ID that you pass in. So if the element has an ID attribute set to a certain string, you can retrieve it using this function. And then finally, there are some other important miscellaneous properties. For example, you can get and set the attributes on a tag and remove a given attribute from an element. There's also a property called inner HTML, and that will give you or allow you to set the HTML content of a given tag. And again, that's for HTML documents, not for XML. Simply by passing in a text string that will contain well-formed HTML. So you can change the contents of a document. And then finally, there's the data property, which gets the text data of an element, comment, or text node. So throughout the rest of this chapter, we're going to be exercising many of these functions to perform various operations on XML content and in our web pages. So feel free to refer back to this video if you need to, but I'll be explaining these functions as I use them throughout the rest of the chapter. Let's begin working with the document object model by seeing how we can use the DOM APIs to discover information that's in a document. So here in VS Code, I'm going to open up DOM inspect in my chapter 4 start. And this is a pretty simple HTML file. If you scroll down in the HTML, you'll see I've got an XML tag here, which I'm using to embed my business card XML content into the web page. And in case you're wondering, yes, this actually is perfectly fine to do within HTML. The browser will parse the XML tag just like any other tag. It just won't do anything special with it. It will exist in the page's model as an unknown element type. In the real world, you'll probably see XML used in a variety of ways. So typically your XML data will come from some call to a web service, or it will come from a database, or you will retrieve it using an API and then operate on it separately. Later in this chapter, we'll see how to load XML from an external source. But in the interest of keeping this example simple and self-contained, I'm embedding the XML content directly into this web page. So if we go up and look at my script tag, I've got some JavaScript. And the JavaScript is a function called display business card data. And I'm adding an event listener for when the user clicks this button down here in the web page. So when that button gets clicked, it's going to call display business card data. And in that function, I'm going to use the DOM API to work with the XML data. So first, I need to retrieve a reference to the XML data in the web page by calling the get element by ID DOM function to get the XML element. And you can see it has an ID attribute named XML data1. So I'm going to set this variable equal to document. I'm going to call get element by ID. I'm going to pass in XML data1. All right, so then I need to use the get elements by tag name, which is another DOM function to get the business card element that's inside the XML tag. And since there's only one business card, right? Remember, so get elements by tag name returns an array of elements, even if there's only one. So there's only one business card. I'm going to have to just pass in a 0 index to get me the only business card element. So for this variable, I'm going to assign that to, and I'm going to call XML data1 dot get elements by tag name. And I'm going to be looking for the business card tag. And there's only one of those, so I'm going to pass in 0 for the index. So for the rest of the function, I'm going to use the DOM to get the name and the email information out of the business card. So what I'm going to do is set name equal to the string name plus, and I'm going to, on the business card element, I'm going to call get elements by tag name. And that's going to be the name. Yep, and that's a capital N, okay? And once again, there's only one of those, so I'm going to use 0. And then I need to get the text content inside of it, right? So the name tag is an element node. And remember, the text inside of it is a text node. So what I need to do is get the first child, and then I need to get the data from that text node. All right, then I'm going to do the same thing for the email tag. So I'm going to set that equal to email plus, and I'm going to do the same thing. I'll just copy and paste this. So copy and paste. And instead of the name tag, I want the email. All right. Okay, so now I have the name and email data from my XML. And then the last line of the function just displays an alert with the name and email data that I've retrieved from the XML. So let's go ahead and save. And then I'm going to right click and choose Open with Live Server. All right, here's my web page inside the browser. I'm going to click on Show Business Card Data. And sure enough, you can see that the name appears along with the email. So just by using some basic DOM APIs, it's pretty easy to discover and inspect the various parts of XML in your document. We've seen how to use the DOM API to discover and extract XML document content. In this example, we're going to see how to use the DOM to create new XML content. So let's open up our DOM create example file. And some of this script should be familiar to you if you did the previous exercise. If you haven't, you should probably go back and do that so you can understand what's going on here. So I have a function in JavaScript named display business card data, and it's the same code from the previous example in the chapter, but now it's complete. And the main difference for this example is that instead of loading the XML data from within the web page, we're actually going to programmatically create the business card data using this function, create business card data, and we're going to fill out this currently empty XML section right here. So my web page has two buttons, one for creating the business card data and one for showing it. And the data will be created, and we're going to populate this XML tag now. So let's fill out the function to create the XML data. All right, so I've already got some code that gets a reference to the XML tag that's in the web page. What I need to do first is create the business card tag that will hold the data. And to do that, I'm going to use the create element function, which is on the document. I'm going to call create element. And I'm going to create a business card element. And to keep this example short, I'm just going to create the name and email tags and ignore the phone tags for now. So let's go ahead and create the name tag. So same story. I'm going to call that name tag. And I'm going to create the element called name. And now I also need to create the text content for the name tag. And remember, that's a separate node type. Okay, I need to create the text node that goes into the name. And I also need to place that text node inside the name tag. So I'm going to do that in one fell swoop. I'm going to call name tag, and I'm going to use the append child function. And I'm going to create a text node. And that text node is going to have the string John Doe in it. And then once I've appended that text node inside the name tag, I then, of course, have to put the name tag inside the biz card. So I'll do that here. All right. And now let's do the same thing for email. I'll just copy and paste this, and we'll call this email tag. And let me go ahead and replace those. This, of course, is going to be email. And I'm going to put an email address in there instead of the name. So that's going to be john@example.com. All right. And then finally, let's add the finished business card to the XML tag. So I'm going to call XML data1, which, remember, that's this reference right here. So we got that element in the web page. And I'm going to call append child to add the finished biz card. All right. So once this function gets executed, it will create the new content and add it to the XML tag in the page. And then when I click the display button, the content will be extracted from the XML tag, like in our original example, and displayed in an alert. So let's go ahead and try that out. I'm going to save this, and let's bring this up in our live server. All right. So first, I'm going to open the developer tools so you can actually see what's going on inside the web page. So here in my browser, all right, I've got my source here, and you can see that the XML data is currently empty. So what I'm going to do is click on the create button, and you can see that the XML tag has now changed. If I expand that, you can see that there's now a business card tag with the name and the email inside there. And if I click the show button, you see that we get the same result as in our original example from earlier in the chapter. So now we're both extracting XML data and we're creating new XML data on the fly using code and the DOM API. I mentioned earlier in the chapter that XML data is usually loaded from an external data source. So let's take a look at how to accomplish that. Let's open up DOM load in our editor. And it's basically the same example as we saw earlier in the course, except if we scroll down, you'll notice that there's no XML tag with data embedded in the web page. I have a file named businesscard.xml that contains the data, and we're going to build the code to load this file and construct an XML document from it. Then I'm going to call the same function we saw earlier in the chapter, which is this display business card data, to display the name and email information that's coming from the loaded data. So first, let's write the function to load the XML from the file, and that's going to be this function, loadXMLDoc. I'm going to use the fetch function that's built into the browser to retrieve the contents of the XML document. And since this function is asynchronous, you can see right here it's async, I need to use the await keyword to get the result. So I'll write var doc equals await, and I'm going to call the fetch function, and the parameter to this function is going to be the URL of the document I want to load. So I'm going to go ahead and use that here. All right. So once the file is loaded, I need to get the text content using the text function. And that's also asynchronous. So once again, I need to await for the result. So I'll make a new variable called response, and I'll call await doc.text. So once I've loaded the document, I get the text out of it. So once I have the text content of the file, I can create an XML document by using the built-in document parser that's in the browser. This is available using the DOM parser object, which has a function called parse from string. So I'm going to pass the text into that function, and that will give me my fully formed XML document, which I can then return from this function. So I'm going to create a variable called XML, and that's going to be a new DOM parser, and then I'm going to call parse from string, and I'm going to parse the response text that I just got, and I'm going to parse it as text/XML. That's important. You have to have that MIME type in there. And then once I do that, I'll just simply return the XML. All right, so now I can use this function to load any XML file. So in my function to display the business card data, notice that I call loadXMLDoc, And then because this is an asynchronous function, I have to use a promise. So I call load XML doc, and then when it's complete, right, I've got this block of code that will execute once the loading is finished, right? So this is done to avoid blocking the UI thread in the browser so that in the case of a giant XML document, the user doesn't get, a frozen or janky user experience. So when the load XML document function completes, the then function is called with the result, which in this case is my fully formed and parsed XML document. And I can then use that content to inspect the XML data, just like I did in the earlier example. So in this case, BizCard will be coming from the XML document we just created instead of me getting it from the web page. So let's go ahead and run this. All right, and when I click on the Show Business Card Data function, oh, look at that. Sure enough, the data is loaded from the file, and we can see the name and the email data in the result. The previous examples in this chapter focused on using the DOM APIs to work directly on the XML data. For this example, we're going to combine the different techniques from this chapter to create new HTML content from XML content, and we're going to use the DOM APIs to do this. So let's open up DOM build. And I've already got the code in place to load an XML file, which if you haven't done the previous example, you should go back and see how this works. So I'm going to load my XML document. I've got a few functions we need to fill in to build the HTML content from the XML. And we're going to start with the create card element function. So this function is executed when this button here in the web page is clicked. It will read the data from the XML file, which contains my business card, which again, we saw this earlier in the chapter. So it's going to read that data and it's going to display it in the web page. And we have an empty div in the web page down here. You can see this card container. So this div is going to hold the new HTML. And you can see that first, if I scroll back up, so after loading the XML data and retrieving the business card root element, the create card element function creates a div tag and then sets the CSS class for that div to the business card class, which is defined in my businesscard.css file here. You can look at this on your own time. So here I'm using the DOM API functions not to create XML content. I'm creating HTML content here. All right. So for the sake of brevity, we're just going to create HTML for the name and email parts of the business card. So let's create the name section first, which will be handled by the create name section function. So first we need to create the div element to hold the data. So I'm going to create a variable called name section, and that's going to be on the document. I'm going to create an element, and I'll create a div element. And then on the name section, I'm going to use set attribute to set the class attribute to name. So then we're going to add the name text to the div. So I'll create a name string variable, and that's going to be a text node. And the text node, oh, actually, it's not going to be a string. Hang on. There we go. So I'm going to create a new text node. And what I'm going to do is get the current card, which is the argument to this function. This is the XML data, right, which contains the card information. So I'm going to get the elements by tag name, and I'm looking for the name in the XML, and there's only one of those. So I'm going to get the first index, and then I have to get the first child, and then the data. And then, of course, I need to put that new text inside the name section div. And then I return the completed div to have it added to the page. So we're going to return the name section. And then we'll do the same thing for the email section. And I can just copy this code from the name section because it's almost the same, right? Only in this case, it's going to be called email section. And then we're going to set the name of the class attribute to be email instead of name so that the CSS lines up. And this is going to be the email stir, not the name stir. We're going to be getting the email, not the name. And we have to finish off by working on email section and, of course, the email string. So let's copy and paste that. Okay, so once these two sections are completed, we can just call these functions and add the completed divs into the HTML of the page. So let's do that. So the new name is going to be create name section. And we're going to pass in our XML data to do that. And then in the new card div that we're creating, I'm going to use append child to add that to the page. And then I'm going to do the same thing with email. So I'll just copy and paste this. And so the new email, and we're creating a email section. All right. So once we've created these new sections, we add them to our div that's going into the web page. And once we've created the new div, we get the element by ID of the card container, which is this div here. So we get that div, and then we put our new card div into that container. So let's save and let's run this in our live server. And I'm going to click create business card element. And there you can see that the new business card is being created. All right. So we've created HTML based on the values in the XML file that we've loaded and parsed. And you can see that we only created content for the name and email tags. So I would suggest maybe pausing here and taking a few minutes on your own and try adding some content to represent the phones, right? We didn't do the phones in the XML. Let's go back to the code really quick. If you look at the business card data, right, we've got the phones here. If you're feeling a bit adventurous, maybe stop here and try adding those phones and pick up where I left off. All right, time for a programming challenge. This programming challenge will make use of the techniques we learned about during the chapter to build HTML content from an XML file. And I'll demonstrate the finished example so you can see what it should look like when you complete your challenge. So here in the start folder for chapter 4, this is the XML file that your code is going to use. So notice it's slightly different from the business card data we've been using. In this case, there are multiple business card elements contained within a root tag called business cards. So you're going to have to work with multiple business card elements in this challenge. So now let's look at the finished HTML file. What I'm going to do is bring this up in the browser with my live server so you can see what it's going to look like. So when I click on the create business card elements function, notice that the page gets populated with the business card elements that are in the source XML. And notice that this time we're including all of the data in each business card, right? Name, phone numbers, email address. Now I've provided a starting point for your solution to the challenge. So if we look back here in the code and we go down to the start folder, you've got this challenge start file right here, okay? And I've clearly indicated where your code should go. So the code already has a function to load the XML document, and it sets up an event listener to listen for the button click. You need to do the rest, okay? So go ahead, try the challenge. Feel free to copy and paste code from previously in the chapter, and then I'll be back to explain my solution. All right, let's review my code for this challenge. So we needed to load the XML for this set of business cards and then build HTML to represent each one. So if we scroll down to my code, right, remember we needed to fill out the create biz cards function. So My code starts by using the load XML doc to load XML file, right, which is the starting point code that I gave you. Okay, we already have this function here, load XML doc. And in create card elements, I simply call load XML doc, and I use my then handler to call a function that I've created called create biz cards. So let's take a look at create biz cards to see what it does. So this function takes the XML document and builds HTML section one at a time. So I use the get elements by tag name function to get the list of business card elements in the XML. In previous examples in the chapter, there were only one of these, but now there's multiple ones, right? So I think there's 4 total. And so I have to then have a loop that loops over the length of that array to create the div tag for each one of the business cards. So each card goes inside of its own div element, which is this line here. And I set the CSS for each business card on the div that I create. And then I wrote individual functions for each section for the name, the phones, and the email, right? Each of these functions returns a div element with the new HTML inside of it for each section. So again, if we scroll back up, you'll see that this is very similar to the code we saw earlier in the chapter. So create name section is pretty much the same as the original, right? Create email section, also we saw that earlier. The only real difference was that I created a function that creates the phones. And remember, there's multiple phone numbers inside each business card. So I use get elements by tag name to get all the phones. And then I have to have a loop that goes over all the phone numbers. And I create a div for each one of the phones. All right. So it's a little more complex because of the multiple phone numbers. So as each of those sections is created, you can see that each one of these functions returns the new div. And back in my create biz cards, each one of those divs, as it gets returned, gets appended into the overall div that's holding all the business cards. And then this happens until all the cards are added. And then we return the finished result. We put each card into the page, right? So taking this approach, by using the DOM, we can easily rearrange the content to fit our needs. So for example, let's do this. Let's go ahead and move the code for creating the email section. I'm just going to cut that and I'm going to paste it above the code for the phones. Okay. So now let's save that. And one more time, let's bring this up in the browser. And when I click on the button, now you can see, right, that the email content is following the name and then the phones come. So the DOM API gives us a lot of flexibility for arranging the XML content out of the original order. So because I can get each one of these programmatically, I can put it wherever I want in the page. So we get full control over how the XML is transformed into HTML. XML is not the only format in widespread use today to store and represent data, of course. 2 other very common data formats are JSON and CSV. In this chapter, we'll compare XML with these other data formats, and then take a look at some simplified code to show how we can convert XML data to JSON. Then we'll finish up by examining some tools that are available for working with these data formats and performing more intensive conversions. JSON stands for JavaScript Object Notation. It's very commonly used to exchange data on the web, particularly when you're using APIs or application programming interfaces from another service on the web. For example, you might have a program that retrieves weather data from a weather service, and that data might be provided as JSON. It's widely supported, just like XML, across all modern browsers and most of the common programming languages. In some ways, it's very similar to XML in that it is hierarchical, but it's not as rich and human-readable as XML is. CSV stands for comma-separated values. It's also a very commonly used data format, usually employed to represent data from a spreadsheet or a traditional row and column database. CSV is not hierarchical like XML or JSON. It's represented as a flat format of rows of data divided into columns by a separator character, which is usually a comma, but it doesn't have to be. It's a great way to represent tabular data, but it's not a good solution for hierarchical data, and it lacks the validation capabilities that XML has, which we will see later in the course. So let's compare some XML data to how it would be represented in JSON. Suppose I had an XML structure that looks like this, the business card data we've been using throughout the course. In this case, I've simplified it a little bit. I've removed the attributes on the tags. To represent this data in JSON, the structure would look something like this. It's a bit simpler than the XML, but notice that there's no built-in way in JSON to represent attributes on a piece of data. It's just keys and values. You can see how each tag becomes a key in the JSON structure, and the content of each tag becomes a value. For multiple tags with the same name, the data becomes an array of values. In this case, it's the phone numbers. This kind of data format is a very common way for web services to return information, particularly if you're going to be immediately parsing the JSON into a live in-memory object. The CSV format's even simpler. In this case, each business card tag within the dataset becomes an individual row within the CSV file. You can see that each one of the pieces of data is represented in an individual row, and you can see the format's very simple, but much of the information from the XML doesn't directly carry over. There's no attributes. The hierarchical structure of the data is not maintained. So how do you know when you should use XML or JSON or CSV? Let's take a look at some common guidelines. XML is a good choice for a variety of conditions. If the data you are working with has to interoperate with a variety of systems and flexibility is important in how the data is processed, then XML is a good choice. It's also a good choice when extensibility is important and you have to combine data from a variety of different sources into a single data set. XML has very strong data validation and quality checking capabilities, which you're going to learn about later in the course. You can define all kinds of rules that govern the types of information that an XML dataset can contain. And finally, if the dataset is complex and hierarchical, then XML is a good solution. JSON is a good choice for when the data will be immediately converted into live objects for use in a running program. For example, a program that needs to retrieve weather data from a service and then use that data right away would benefit from using JSON because most programming languages can map JSON directly to native objects in that language. Because of its simplified syntax, JSON is also a good choice when parsing and processing the content is absolutely critical and performance is important. Although JSON can handle hierarchical data like XML, it's usually best to keep the data complexity as simple as possible. JSON's a good choice for moderately complex data structures. It's also a good choice when the dataset is not very large. Generally speaking, you want to keep JSON data objects fairly lean, maybe up to a few tens or hundreds of kilobytes in size. Comma-separated values are a good choice when, not surprisingly, the dataset is being exported or imported to or from a spreadsheet. If the data is going to be operated on by a spreadsheet or some other program that expects a CSV format, that's a good choice. CSV is also very human-readable, so if that's a key concern, then you can consider using it. CSV is also good for situations where the dataset just naturally lends itself to being a flattened row and column structure, like when you're working with legacy SQL relational databases. Now, obviously, these are fairly broad guidelines, and there's going to be nuances to each depending on your particular use case. Generally speaking, using these guidelines will be a big help, though, in deciding which data format to use.